How did everything start from nothing? Welcome to this lecture on one of the most profound questions humanity has ever asked. How did everything start from nothing? It is a question that takes us to the very heart of the universe's mysteries. Together, we will explore the incredible theories behind the universe's origin, the processes that followed, and the ultimate fate of everything that exists. Along the way, we'll bridge the insights of science with the philosophical wonder that fuels our curiosity about existence. Let us begin this journey to uncover the beginning of everything and grapple with the enigma of what may come after. The story of our universe begins approximately 13.8 billion years ago with a groundbreaking event we call the Big Bang. Contrary to what the term might imply, the Big Bang was not an explosion in space. It was an unfolding of space and time itself. Imagine the entirety of the universe compressed into an incredible, minuscule point of infinite density and heat known as a singularity. And then, in an instant, it happened. This singularity expanded, not into a pre-existing space, but creating space as it went. Time as we know it began. All the fundamental forces like gravity and electromagnetic energy were born, and with them, the seeds of every star, planet, and galaxy that would eventually form. The Big Bang marks the origin of everything we observe today: space, time, energy, and matter. But this raises a compelling question. If everything started from nothing, what exactly does nothing mean, and how could it give rise to the universe? This question, what came before the Big Bang, has puzzled scientists and philosophers alike for centuries. Before the Big Bang, there was no before as we understand it. Our familiar concepts of time and space simply did not exist. Without these dimensions, exploring what came before is extraordinarily complex. The question itself becomes harder to frame. However, modern physics suggests that even in what we might call nothingness, there could be phenomena at play. At the smallest scales, quantum mechanics, one of the most fascinating areas of science, tells us that empty space isn't really empty. Instead, it buzzes with energy and uncertainty, where particles can briefly flicker into existence and vanish again. This quantum vacuum, as it is called, could hold the key to understanding how everything emerged. There are also intriguing theories proposing what might have preceded the Big Bang. For example, the multiverse hypothesis suggests that our universe is just one bubble in a vast, infinite cosmic sea of other universes. Another fascinating idea is the cyclical model, in which the universe repeatedly expands and contracts in an eternal cycle of big bangs and big crunches. Ultimately, the true nature of nothingness remains elusive, stretching the boundaries of both science and philosophy. Even as we attempt to answer this question, we're reminded of how much there still is to uncover. After the Big Bang, the universe began to evolve. This process started with unimaginable energy spreading outward, cooling as it expanded. Within just fractions of a second, fundamental particles like quarks and electrons began to form from the hot energy of this explosion. As the universe continued to cool, these particles combined to create protons and neutrons, which later joined together to build the first atomic nuclei. Fast forward roughly 380,000 years, and the universe had cooled enough for these atomic nuclei to capture electrons, forming the first stable atoms, primarily hydrogen and helium. This event, known as recombination, allowed light to travel freely throughout the cosmos, leaving behind a faint glow that we can still observe today as the cosmic microwave background radiation. This radiation serves as a snapshot of the universe at its infancy, providing invaluable clues to how it all began. But this was just the beginning. Over millions of years, gravity began to pull matter together into clouds, forming the first stars and galaxies. Within these stars, nuclear fusion created heavier elements such as carbon, nitrogen, and oxygen, the very building blocks of life. These elements scattered across the universe in stellar explosions, creating rich cosmic material that would eventually form new stars, planets, and ultimately life as we know it. The story of the universe's formation is a testament to its incredible complexity and wonder. But even as we unravel these processes, we're left with the deeper question. Was the universe created by chance, by necessity, or by something we've yet to imagine? To answer these deeper questions, scientists have developed a range of theories and interpretations about the origin of the universe and why it behaves the way it does. Quantum mechanics, for instance, reveals that uncertainty is a fundamental property of nature. This randomness may have played a role in the emergence of the universe from the quantum nothingness we discussed earlier. Another fascinating concept is the fine-tuning of the universe. Many features of the cosmos, such as the strength of gravity or the charges of fundamental particles, must fall within extremely specific ranges for stars, planets, and ultimately life to exist. Some scientists explain this through the anthropic principle, which suggests that we observe a universe capable of supporting life simply because if it didn't, we wouldn't be here to observe it. Others take it further, proposing that this fine-tuning may point to a purposeful design, while still others argue it could simply be a consequence of how physics operates. Alternative theories, such as string theory and brain cosmology, propose that our universe is just one of many layers or dimensions in a far more complex reality. These frameworks provide incredible insights, yet the debate about chance, necessity, and purpose remains wide open. As science progresses, new discoveries will continue to challenge and refine our understanding of the universe's origins. If something with a beginning has an end, then what might the future hold for our universe? The question of its ultimate fate is as fascinating as its origin. Based on current evidence, there are several possibilities, largely driven by the role of dark energy, a mysterious force causing the universe to expand at an accelerating rate. One scenario is the heat death or big freeze. In this view, the universe will keep expanding indefinitely, causing galaxies and stars to drift farther and farther apart. Over billions of years, stars will burn out and energy will dissipate until the universe becomes cold, dark, and lifeless. Another possibility is the Big Crunch. If the universe's expansion were to slow down and reverse under the pull of gravity, it could collapse back into a singularity, perhaps leading to another Big Bang and a cyclical process of cosmic rebirth. A third, more dramatic possibility is the Big Rip. Here, dark energy continues accelerating the universe's expansion to the point where galaxies, stars, planets, and even atomic particles are torn apart. Space-time itself would break down in this violent end. Each theory provides a glimpse into the distant future, but leaves room for uncertainty. As with its beginning, the universe's fate remains a source of both mystery and wonder. Behind every theory and observation lies a deeper sense of curiosity, a drive to understand not just how the universe works, but why it exists at all. Science has made incredible progress in explaining the mechanisms behind the universe's origin and evolution, yet it also reveals the boundaries of our knowledge. At these boundaries, science meets philosophy, opening up profound questions about existence and purpose. Are we mere cosmic accidents, or is there a deeper reason for our existence in the universe? What is the role of humanity in understanding this great web of creation? These are questions that transcend equations and experiments, inviting us to reflect on our place in the cosmos. Appreciating the universe isn't just a scientific endeavor, it's also an act of wonder, a way of connecting to something much larger than ourselves. The fact that we are capable of asking, "How did everything start from nothing?" is itself extraordinary. It suggests that the human spirit, shaped by billions of years of cosmic evolution, is part of the universe's ongoing story. As we conclude, let us reflect on what we've explored today. The Big Bang, the quantum mysteries of nothingness, the formation of stars and galaxies, and the ultimate fate of the cosmos all lead us to profound and humbling insights. While science provides us with tools to probe the vastness of existence, it also reminds us of the limits of our understanding. We've seen how the universe came into being and how it evolved into the majestic cosmos we observe today. At the same time, we've confronted the enigma of its potential end, whether through an infinite freeze, a fiery collapse, or an explosive rip. But perhaps the most important takeaway is that the universe's mysteries are not obstacles. They are invitations, opportunities to explore, to imagine, and to continue asking questions. That journey is what makes us human. Thank you for joining me in exploring this extraordinary topic. Remember, the universe's story is not just a tale of beginnings and endings. It is our story, written in the stars and unfolding with each discovery we make. Let us keep asking, wondering, and embracing the beauty of not yet knowing all the answers.